Hello, my name is John Nagoski, and I'm a native speaker of English from Wisconsin in the USA. I would like to introduce to you my English reading channel with questions and answers.
Earth 4.5 billion years ago. No water, no life, no future. A series of disasters turned this lifeless wasteland into a blue planet with ice-covered mountains, lush jungles, and twisting canyons. It's a story 4.5 billion years in the making, and it starts with a bang. Just over 4.5 billion years ago, something happened to our world that would change it forever. A planet the size of Mars collided with our own, fusing them both together. The collision ignited the engine that would ultimately change our world, transforming it from a desolate wilderness into the verdant planet we know today. We're learning new things about our planet every day. And this is not the kind of geology that can be examined in a lab. To understand, it takes a new kind of scientist, one who will go to extremes to get answers. To crack the real Earth story, they have to live it. What they have discovered is that wave after wave of catastrophe and cataclysmic violence would combine to create the world as we know it. This tranquil blue planet was forged by Armageddon. 4.5 billion years ago, the Earth was a volcanic hell. The gases from this chaos formed a primitive atmosphere. Hydrogen combined with oxygen in that atmosphere to create water, and eventually covered the planet. There was no land in the vast seas of the early Earth, just water, stained green by iron leaking from the Earth's core. So, where did land come from? The answer lies not on the surface, but deep in the heart of the planet. The result was lava, rock heated to such enormous temperatures that it turns to liquid. This is the essence that created the world, in the oceans of the early Earth, where the crust was only 3 miles deep. Lava would push up to the surface through weak points known as hot spots, dotted all over the planet. And off the coast of Hawaii, geologist Lloyd French can see it in action today. He is observing a process that's been happening for more than 4 billion years. This is island building at its finest. We're dealing with molten rock here. It's not like it's a fireplace and firewood. This is actually rock that's on fire. Liquid magma from the furnace below forces its way through the crust. As the lava hits the water, it solidifies. You see how it crusts over as the water hits it. It looks like inches upon inches, and then slowly feet upon feet. And before you know it, you have a fairly well-developed and new island. As more lava builds on top of the hardening crust, new land rises from the sea, and an island is born. 4 billion years ago, our planet was a world of island volcanoes, rising from a noxious green sea, but that's only half the story. To turn islands into continents takes a force even more unstoppable than lava. The entire surface of the world is made of tectonic plates, segments of the Earth's crust that spread from weak spots in the ocean floor and drift over the magma within the Earth. Their edges are marked by massive amounts of volcanic activity because when plates collide, all hell breaks loose. As one plate grinds under the other, it forces the crust upwards into giant mountain chains, creating land in an inferno of volcanic activity. This activity is called continental drift, and this is the force that builds the world. For billions of years, continental drift would build bigger and bigger land masses until about 1.8 billion years ago, a gigantic collision created the conditions that would revolutionize life on Earth. Adventurer Will Gadd has come to the Grand Canyon, where geologist Karlstrom will show him evidence of that event. At the very bottom of the canyon lies a layer of rock that is more than 2 billion years old. This rock marks the moment when a continent was created. About 1.8 billion years ago, a small group of prehistoric islands got in the way of a giant landmass as it drifted across the Earth's crust. That landmass would one day become America. It bulldozed over islands, crushing and twisting them into a cauldron of fire that fused them together into one gigantic continent, the world's first supercontinent, Rodinia. The coastline of Rodinia provided the nursery that enabled life to make a truly spectacular leap. In its shallow waters, single-cell organisms combined to form primitive algae that would convert sunlight into oxygen. And oxygen created the conditions for the next leap forward, animal life.